The first signs of system strain are surprisingly mundane. While we watch for digital anomalies or rogue code, the actual signals are appearing in our immediate physical environment. These signals look like a sudden drop in your kitchen's water pressure. They look like an unexplained spike in your local electricity rates, or a steady increase in neighborhood rolling brownouts. We are staring so intensely at the code on our screens that we have become blind to the physical world housing it. Artificial intelligence does not scale inside a vacuum. Treating these models as purely virtual systems obscures the immense physical resources required to sustain them. The scaling of intelligence is now putting direct pressure on the physical planetary systems that keep human civilization running. In the current world of AI governance, experts are divided into narrow silos. They spend their time debating model safety, algorithmic alignment, and software security. This diagram shows the disconnect. On this side, we have a contained list of theoretical software debates. On the other is the physical reality of where intelligence is actually scaling: municipal water pipelines, massive power grids, and sprawling rare earth supply chains. Governing AI as isolated software fails because the technology relies entirely on these interconnected physical ecosystems to function. This creates what is known as an infrastructure metabolism. Software has transitioned into a form of physical infrastructure with an unyielding, growing appetite for resources. What begins as digital logic eventually transforms into steel, concrete, and copper, altering how planetary resources are allocated. We can trace the path from a single line of optimized code directly to the dropping water pressure in a local municipality. It starts with a locally rational decision. A tech company optimizes a software process, which increases a server's compute load. That load creates heat, which results in an increased cooling demand. When thousands of these small micro trade-offs aggregate across a global network of data centers, they create a slow continuity drift. The result is a massive collective draw on a single municipal water reserve. No error codes are triggered during this process. The software performance metrics remain perfectly stable and green, even as the connected water reserve dips into critical red levels. The macro operating conditions of our planetary infrastructure are being altered by a series of perfectly rational, localized decisions. The core question facing society is shifting away from simply asking, can AI scale? The question is whether intelligence can scale without destabilizing the systems that sustain civilization itself. We face a specific psychological danger with slow-moving crises: the human tendency to quickly normalize the consequences. There is a risk that we will accept higher utility bills, weaker electrical grids, and resource scarcity as the new normal, without ever recognizing the software that caused it. This is why planetary continuity must become the ultimate objective of AI governance. To navigate the AI revolution, we must stop fixating entirely on the digital models and start protecting the physical planetary ecosystem that houses them.